Alright, so in this video, let's look at another example of reduction of order, but this time it's going to be a much harder problem. So, I rewrote the problem here. So, the first step is to rewrite our y2, right? So, our y1 is sine of x. They give this to us. They give us y1. So that means we don't have to go through the proposing. We don't have to do the solve for r or whatever, right? We just use what they give us. So they give us y1 is sine of x squared. So now, right here, we go right to y2. So y2, remember, is just v times y1. So v times sine of x squared. Now we take the first derivative of that, which would be, if we do the product rule, we would have v prime, right? And by now, you should be very familiar with the product rule, hopefully. Plus 2x v cosine of x squared. If you're not familiar with the quotient rule, product rule, I would go and practice it. Also, in differential equations, you should never have to use the quotient rule. You should always be able to just rewrite it so you can use either chain rule or product rule, right? It's so much more simple. You should never have to do quotient rule. Where was I? Okay, that's it. Now y2 double prime. Look at the first term first. So we're going to have v double prime sine of x squared and v prime first 2x v prime cosine of x squared, right? Derivative of sine is positive cosine. And then now looking at the second term, so I'm going to group it together like this, where this is one, this is the other one, and the 2 is just there to follow, right? So the first times the derivative of the second would be the 2 carries. This would be what? Times 2x v times an x times a v, right, times sine. Okay, so it would look like this. So we have 2. So first times the derivative of the second. That's how I usually do it. I do it first times the derivative of the second, and then plus the second times the derivative of the first. That's how my professor did it. He did it backwards to most other people. But 2 times the first times the derivative of the second. So 2 times the first times the derivative of the second is 2x sine, negative 2x sine of x squared. So that'll, and then we have plus, that's bothering me, plus 2 times the second times the derivative of the first, which is just going to be v, just v. Okay, so let me rewrite that. Plus 2x v prime cosine x squared, that's a 2, plus 2x, minus 4x squared v, sine of x squared, and then plus 2v cosine of x squared. Okay, now let me just check my notes, make sure that's right before we continue. So negative 4x squared v sine of x squared. Yep. 4x v prime. Wait, what? Oh, hold on. When I did this term here, oops. This was times 2, right? My bad. Yep, plus 4x v prime cosine of x squared. 2v cosine x squared. Yep, and a minus. Where was I? Yeah, minus 4x squared v sine of x. Yep. Okay, so we're good. Now using this, and this. And this. We're going to plug this back into our original equation. So we're going to have x times y prime. So I'm going to do this out in my head. So v double prime x sine of x squared. This is going to take up multiple lines, if you can't tell already. Plus 4x squared now, v prime cosine of x squared. Minus 4x cubed, v... Do any of these combine? Hold on. Before I can... I don't think they do. That's unfortunate. Plus 4x cubed v... where was I? Oh, I was on this term. V sine of x squared plus 2vx cosine of x squared. Okay, so that's our first line. That's the y2 prime. Now we have minus y prime. So we have minus y, just y prime. So we just rewrite y prime. So v. So here, let me distribute the negative. So minus v prime sine of x squared. Now I'm getting that from up here, right? From up here. This line right here. So plus 2x v cosine of x squared. And we have one more line. We have plus 4x cubed times v sine of x squared. So just v sine of x squared. Okay. This is one... I could fit this up here, actually. Okay. Equals 0. Right? So this is one equation. So now let's see what we can combine here. So remember, first things first, we want no v's, right? We want no v's left. So let's look at the v's terms first, for terms that just have v in it. So let's see here. We have this one. We have this one. We have this one. We have this one. And I think that's it. So immediately I see that these two cancel. Oh, wait. I was just going to say we have an issue, but I forgot to multiply that negative in, right? It was minus y prime. I forgot to distribute that negative here. So if anyone caught that, that's good. So yeah, these do... See, good thing you check the v's first, because you check for signs and whatnot. You know those two should cancel. That's how I was able to check myself. Okay, so now we're left with... We have no v's left, so now we have... Let me rewrite this. Yeah, minus v prime sine of x squared equal to 0. So now this is what we're left with. Now we're going to do a little bit of some trig substitution. Some trig simplification here. Okay, so I'm going to divide everything by sine of x squared, right? So we have two sine of x squares here. I'm going to divide everything by sine of x squared. So then this would become v double prime x plus 4x squared v prime. Now remember, cosine over sine is cotangent, right? So this would be cotangent of x squared. This is, once again, this is a trig identity, right? Cotangent of x squared. Sine. Let me write it over here. Sine over cosine. Sorry, cosine over sine is equal to cotangent. Okay, so then we have minus v prime is equal to 0. Let me just make sure I have this right so far. X squared. Oh, this is supposed to be a 4. I don't know what that was. Now let me see what we can do. We have, okay, so we have, okay, I see something. We have something in common in these two terms to the right here. We have v prime in both, right? So I can take out a v prime here. Right? And then we can apply our substitution where, remember, u prime is equal to v double prime and u is equal to v prime. So, sorry, this is supposed to be a v. I'm just confusing myself here. I'm going to end up making a mistake. Okay, so we have u prime times x plus v prime, which is u, times 4x squared cotangent of x squared minus 1 is equal to 0. And we have to solve for v, right? So this is already not the nicest looking thing here, right? So I'm going to rearrange this, I guess. Yeah, I'll rearrange this. X u prime is equal to negative u times 4x squared times cotangent of x squared minus 1. I believe right here we could separate the variables, right? We can divide that u over and divide that x over, I think. Okay, let me do it this way. So x du dx yeah. So we actually no, we have to switch the sides, don't we? Yeah. So we're gonna multiply that dx over. Okay, yeah, this is what I'll do. So I'm gonna have x du is equal to negative u times 4x squared cotangent of x squared minus 1. And I'm going to, I multiply this dx over. Now we have this u that needs to go over here and the x that needs to go over here. So this will be, I'll bring the negative over. Actually, no, I'll keep it on this side. 1 over, doesn't matter, I don't think. This is 1 over u times du is equal to negative x times, divided by x, right? Times 4x squared cotangent of x squared minus 1 dx. So now I can simplify that, right? Let's say u is equal to negative 4x cotangent of x squared minus 1 over x. So now we can take the integral. These will be two separate integrals, right? See how I did that? I believe this will work. I just have a sign error somewhere. I believe, let me see. Minus 1 over x. Oh, wait a minute. Oh, yeah. What am I doing? This was already a minus 1 here, right? If I multiply that negative in, this would become positive, right? If I multiply this negative into here, that'll become positive. I forgot about that. Okay, yeah, now we're good. So now this would become natural log of u equals negative 4 that is what's it called? We can, I don't know, we can do u sub for this. Oh yeah, we can do u sub for this one. Okay, so let me move down. Let me make some space here. This is u sub, right? So u can be equal to x squared. I'm just looking at this one right here. U is x squared, and so then du is equal to 2x dx. So we can rewrite this to be integral of negative 4. This x will cancel. Multiply everything by 2. I'm going to pull the negative 8 out of the integral because it's negative 4 times 2, right? And then we have cotangents of u du. What am I forgetting? Oh, it's not. It's not 4. It's divided by 2, right? It's not times 2. It's divided by 2 because you take this because it's gonna look like this. It's du over 2x is equal to dx. Yeah, you divide it by 2, and that x cancels, right? So this will cancel with this x, and that's negative 4 over 2 is what you're left with, which is just 2. So I can just write that as 2. Okay. Anyways, let me erase that so you're not confused. Now that's correct. So now then just plus, this is just the natural log of x, right? Now we do have a plus c floating around over here. Now there's more than one plus c here, right? We have the plus c from over here. But, you know, I showed you earlier in first order what's going on here. Like we have a plus c1, a c2, a c3, and they're all just going to combine and become 1c. So it doesn't matter. Just write the 1c at the end. The integral of cotangent. So let me write this. ln of u is equal to negative 2 times, what's the integral of cotangent? Integral of cotangent is, remember, there's a whole bunch of trig integrals, right? I believe the integral of cotangent is the natural log of sine. Let me look that up really quick. The integral of cotangent is, the natural log of sine. Okay, so it's the natural log of sine. See, I used to have all these memorized, and it's been almost a year since I've done this. So natural log natural log of sine of u plus the natural log of x plus c. Okay, now we still have this u here. We got to plug it back in for u. So natural log of u, this is an absolute value sign, is equal to negative 2 natural log of sine of x squared. I plugged back in for u plus the natural log of x plus c. I'm just making sure that this is right so far. Yep, looks good. Now we can rewrite this this middle term here. So you take the inverse of that, right? How would I do that? And then just square the sine term. Wait, where does that x come from? Oh, okay, I see. So this is just going to become, oh, right, I see what I did. Okay, so remember that this can be rewritten as, right? And this can be, oh, yeah, this is still plus the natural log of x plus c. So we have a little bit of log simplification going on here. So this would become natural log of 1 over sine of x squared plus natural log of x plus c. So now the natural log of u is equal to, now remember, when you add natural logs together, you're going to divide. So we can do it this way. We can do it natural log of x over 1 over sine of x squared, right? That's where I was confused about when I see now. Oh, that's squared, right? Because that's negative 2. Plus c. Now we can exponentiate both sides. And we're getting there. We're getting there towards the answer. So now we're left with u is equal to, that would be c times x over sine squared of x squared, right? All I did was exponentiate both sides. it's going to become e to the c times that. This becomes a new constant. And then let me make sure this is correct. Cx over sine squared x squared. Yep. Okay, now we go back. We solved for u. We have to solve for v now. So we successfully reduced the order. Now we just have to go back and solve for v. So remember, u is equal to v prime, right? So v prime is equal to c x over sine squared x squared. So now we have to integrate both sides. The left side is just v. This right side here, I think we do u sub again, right? Let me see. Cx. Oh, okay, I see what I did. So remember, one over sine is cosecant, right? Yeah, 1 over sine is cosecant. Oh, okay, I know what to do. 1 over sine is equal to cosecant, right? 1 over sine of x is equal to cosecant x. So knowing that, I can rewrite this. Right? And now I would do u sub. So this makes it easier so we don't have, any fractions to deal with. So now we do u sub where let's have u equal to x squared. So then du is equal to 2x dx. So then we'll have v is equal to the integral of 1/2 times, that c is acting as a constant, pull it out, times, and remember this is like a c1, right? Times the cosecant squared of u dx, du now. Okay, so now we integrate this. Remember, the integral of cosecant squared is pretty easy. This is just a basic trig. The derivative of cotangent is cosecant squared, right? So that's pretty simple. So if the derivative of cotangent is cosecant squared, negative cosecant squared. Yeah, the derivative of cotangent, remember, the derivative, this is Calc 1 review, of cotangent is equal to negative cosecant squared of x. So, knowing that, 1/2 c1 times negative cotangent, so I'll pull the negative out, cotangent squared of u. Sorry, not cotangent squared, just cotangent. Let me make sure that's right. And then we're going to have another, let me just, 4, where am I? Oh, down here. 1/2 c1 integral cosine squared u is of c1 cotangent. Yep, we're good. Plus the second c, right? So now we plug back in for u. I should have used a different variable because we just used u for something else, but it's you get the idea. So cotangent always ux squared. So now we have our v, right? I think now we just go back and plug it into our y2 now, right? Because we know, remember what our y1 was given to us. It was, I forget. I have it right next to me. Let me see. y1 was sine of x squared. They gave that to us. So then our y2 was v sine of x squared. So then we just plug back in for v. So then y2 would be negative 1/2 sine of x squared. Wait, I forgot the whole rest of v. c1 cotangent of x squared plus c2 times sine of x squared. Now remember, let me make sure the same thing follows here. We could simplify this further. It looks like, yes. Remember before? Oh yeah, we can definitely simplify this further. I didn't see this. Look, good thing I looked. Cotangent, remember, it was what? Cosine over sine? Yeah. Cosine over sine is cotangent. So then we can rewrite this to be cosine over sine. And then you can see why I did this, because the sines will then cancel with that term. Right? So now let me go ahead and distribute. So now before I distribute, remember for the C1 and C2, remember we're going to assume C1 is going, whatever's with the other stuff is going to be 1, and whatever C is by itself is going to be 0. So we're going to assume C1 is 1, C2 is 0. So then we're left with y2 equal to negative 1/2 cosine, because those sines are going to cancel with this term, plus 0, so that's just it. Okay, so this is a possible solution. But I was just looking at my my work, and it looks like I didn't assume C was 1. You could actually assume C is any positive value. You could assume that C is negative 2, for example. You could assume C1 is negative 2. And if C1 is negative 2, that drops off as well. And you're just left with cosine of x squared. So then our y, so this problem just asked for a second solution, and we just found it. And this is our second solution. So we did all that work just for that, right? You know, it wasn't too long. I've done ones that were far worse than this. Like, especially, my professor was very evil with our quizzes and exams. We had really, really bad ones. Even worse than this. But this is the hardest one I could find in the textbook that I have notes on. So I just decided I'd give it to you. Alright. Anyways, hope you enjoyed the video. Unfortunately, we will be looking at the method of undetermined coefficients next time. I think it's a lot of fun once you get the hang of it. I think it's just a lot of algebra. It is so much algebra. The method of undetermined coefficients. I mean, it is really a lot of algebra. If you're not good at algebra, you will be by the time you're done with undetermined coefficients, right? Anyways, I'll see you in that video.